Okay, so we are still in pressure. So last week you have been taught regarding different type of pressure. So today we are going to continue on the definition of pressure itself in a more general form. So I think this one, most of you might know the definition of pressure. Okay, the equation itself, from the equations, you know it will be force per unit area, right? So force will be denoted by F, and then normally area will be by A lah. Okay, so this is will be the definitions of pressure. So P, P pressure will equals to F over A. That's the equations. The SI unit, so it's normally you need to pay attention, a close attention to the SI unit. So standard SI unit for pressure will be Newton over meter square. Okay, Newton over meter square. So you need to ensure the force will be in Newton, and then the area will be in meter square. Otherwise, you need to do some conversions. So other than that, another form you can describe this one. Newton over meter square will be Pascal. Pascal here, PA. Okay, so that one will be a general form of definition for pressure. So as been mentioned to you, so this is the another equations of it. Okay, F over A. So if given to you, here is a very simple example itself. So if the weight, okay, that's mean the force wise is 100 Newton. Then you have the area of 0.1 here. If you have a 0.1 area here, then you should have 1000 Pascal. So Pascal will be equivalent to Newton over meter square too. Okay, so if you take from the sidewise, so it's a two-dimension, it's not a volume. So if the area is slightly smaller, 0.01 meter square, then you will have more pressure on this one. Okay, 10,000 Pascal itself. Okay, so this is one form of it. Okay, another form which you can relate pressure in a liquid will be, we always consider the relationship between the pressure and the depth itself. Okay, so the equations will be P, still denotes the pressure. Then you have rho GH, rho GH. So rho will represent the density of the substance. Okay, density of the substance. Okay, so if you have water, then you know what's the value, right? What is the density for water actually? Universal fluids itself. Any idea of that? Any one of you? I think this one you learned it during your science class, during the Form 1 to Form 3, or science stream. If you are in the science stream, I think this one. Anyone have idea about what is the density for water? No?
No, sir.
No, So if no, then you have to remember this one. Okay, so the density for water in a universal form, then you take this one as 1000 kilogram over meter cube. Okay, so please write this one down, please. So water, H2O, H2O, the density will be always remain at 1000 kilogram over meter cube. Okay, so this one is 1000. Okay, then you have gravity. So gravity, as you know, it will be meter over second square. Okay, so what is the value of gravity? Gravity, what is the value?
0.81.
Yes,
0.81.
9.81. Very good. So it will be 9.81. 9.81. And how do you correlate pressure? with the height itself, the depth of the fluids in meter. So this is equivalent to distance. So the depth. So if you go 20 meters down the water, so what is the pressure that you will be uh, having on that 20 meters? So you can have a very simple question just like that. Okay, so this is another value that you need to consider, another equations that you need to memorize for these scripts, because we are going to use these equations quite frequently actually. Okay, so far on this, any questions that you would like to ask?
No, sir.
No? Okay, so I think this one pressure head also equals to the definition of it. Okay, you can read it through from your CDOS. We will go straight away to the example here. Okay, we go straight away to the example here. So please calculate the pressure at 1 kilometer depth of the seabed in the Pascal and bar unit. Okay, so please calculate. Your answer should be 1. The first one will be in Pascal unit. The second one, they want it to be in bar form. Bar. So as I mentioned to you, the bar will be in 10 power of 5. Okay, 10 power of 5. So at here, we don't use the universal water. Since seawater, you have more than 1,000. Normally, it will be slightly higher than 1,000. Okay, so you have 1,025 kilogram over meter cube here. Okay, so can you please try this? So I just drop this so that we can bring into the words. Okay, class, please have a try.
Gambar eh, sir.
Oh, tak dapat tengok sudah.
Tak dapat.
Wait, no. Okay, I put it in words. Okay. Okay, so let's have a look on the solutions. Okay, so the equations that they utilize, so it's a very good start here, very good practice. Both of them start from the equations itself, that the equations that you are going to use, okay, for the solutions. So the density here is given 1025 times 9/1. Okay, so it's kilometer. Okay, so kilo will be 1,000 meter. You need to ensure the distance SI unit will be in meter. So you need to do a conversion, which is 1,000. So this is absolutely right. So it will give you the answer of this is 10 million, right? 10 millions plus. So for this one also, for Ahmad Abdul Hakim also, okay. So same solutions. Okay, just the units. This one correct, right? 10 million also. Okay. So Newton over meter square, and then this one Pascal. Okay, so both of them have the same answer actually, but okay, Ahmad Abdul Hakim, for your solution, this one, maybe you have some minus deduction of marks here lah, since they require you to give in Pascal, right? Okay, so you need to do a just be right equals to Pascal lah. You will be in a better form because it's actually stated in the questions. Okay. Okay, next one here. Jeremiah, you don't provide any answer for bar.
Oh, I forgot, sir.
Okay. So actually you miss out the second part. So if this one bar give you 2 marks or 3 marks here, then you lost out on that 3 marks lah actually. Okay. because it's not necessary for you to calculate. Okay, you just need to do a conversion of it. 1, 2, 3, 4, 5, right? So 100.5525 bar, which is the correct answer here. Okay, 10 power of 5, huh? So here you jump 5 to the front. Here you have 100.55 bar lah. So that will be the correct answer here. Okay, class. Any one of you have different set of answer or different set of solutions that you want to rise up?
No, sir. Same
Sam?
answer.
Answer.
Okay. No questions on this? So it's pretty straightforward. Okay, so if you don't have any questions, then I will provide you another question. So this will be the last example regarding pressure, here. Okay, the next one we are going to shift to topic number 2 will be the characteristic of the fluids. Okay, so this one will be some sort of the last examples regarding the pressure. Okay, topic number 1. So I would like you to try this one out also. Okay, a recap on last week lesson, and also the second part will be on today lesson. So I will give you 5 minutes to try this one out. We have a look on the proposed solution here. So you have a modern pressure gauge attached to a boiler that show a reading of 15 bar. So if the atmospheric pressure is given to you 101 kilopascal, so the first one that you would like to determine will be absolute pressure. Then you need to provide the answer in kilonewton over meter squared. So let's have a look on the proposed solution here. So the equations that your friend utilized here is PA equals to PG plus P atmosphere. So I think the equations is the correct one. Okay, then PG. Okay, so any readings, any pressure reading from the pressure measurements apparatus will be the gauge pressure. So if 15 bar here, then ATM here will be 101 kilopascal. So what he did was, okay, convert this one to what do you do here? Bar, then times with 100 K bar. So that it will you convert to kilo lah basically. Okay, convert to kilo. So kilo 3. This one is correct. The answer is correct. Okay, answer, then you get 1,500 plus 101. So it will give you the answer of 1,601 kilonewton over meter square in the unit that the questions wanted lah. Okay, but over here is quite confusing here. Over here, normally you don't put in the unit itself here already lah. Okay, normally you ought to remove here, then in the better forms, maybe you times 10 kilo, 10K here. So then you leave it K also. Okay, so this one you remove it lah. Okay, because that here will be times 10 power of 5 already, you see. Then you times again this. So it will be more than that already. So your stepwise here, you need to improve. So this one, you need to remove it. Okay. Over here, you remove.
Okay, sir. Can. Sure.
Okay. So the rest of you, do you have the same answer? For the rest of you, do you have the same answer, please?
Yes, sir.
Any questions that you want to ask?
Sir, how many marks is it? Good question.
Can you repeat?
How many marks do we get for this question?
How many marks?
Yeah.
Maybe 1, maybe 2, 3, because the confusing part will be only the conversion. Maybe 4 marks here. Okay, 1 on here, then the unit conversion 1 marks, then your steps, then your answer. Okay. Any other question, please? Okay, from the second part here, so you need to determine the pressure head of the water, H. What is the depth that will be equivalent to the pressure? So you see, you at here in your questions actually, you have a lot of pressure to consider, right? So you have a gauge pressure, you have an atmospheric pressure, you have the absolute pressure. So which pressure actually you are going to select to become the pressure, okay? To become the P value actually. So you have P equals to present symbols, then rho, right? Rho GH. So very obvious here. Very obvious here. Here you can have, as I mentioned to you, water. This if is there is no even though it's a sea water levels and so on, since they don't provide you any density, as I say in a universal form, the rho for the liquids will be 1000. Okay, then times 9.81 here. Very clear, right? Then they give you the depth value here. So over here, actually, which pressure that you are going to select? Is it PA, PG, or P atmosphere?
PA,
PA,
absolute pressure.
absolute pressure. Okay. Any other suggestions? Okay. So I think this one you need to know that actually the pressure that we are going to consider for this kind of situations will be PG. PG. Okay, the gauge pressure itself. Because in a normal situations, the atmosphere pressure will become the datum level itself. Okay, because in everywhere in the earth actually you are feeling the atmosphere pressure. Okay, so the one indicates the pressure at that particular moment will be the gauge pressure. Okay, not the absolute pressure and not the atmosphere pressure. Okay, so please remember that the one normally we take into considerations will be the gauge pressure, gauge pressure. So over here, please put in the gauge pressure value, which is 10 power of 5, right? So 90, sorry, this one divided. Hence, you will have the answer of, for class, please provide me your answer.
519.
519. Point. 519, that's all. Any other answer, please? So, okay, calculate. No leh, 5 to 9, right?
Yes,
Yes,
sir.
sir.
Right? Meter, eh?
Yeah.
152.9 meter. Okay, hopefully you can obtain the same answer as mine here. So the tricky part will be which pressure to consider. So as I mentioned to you, you will only consider the gauge pressure. Okay, because we have tagged the atmosphere pressure here as the that term line. So